The materials used in this project are available from Jameco Electronics.
Making something that works is an awesome feeling. Making it easy to use and, well, cool looking ups the satisfaction level quite a bit. Plus, it makes your device that much easier to share with others who might not fully appreciate the hard work you put into constructing all the electronics. I like to look at interface design as both a science and an art. It's a balance between sensible ergonomic layout and some sweet retro sci-fi styling of a control panel or a patch bay. Well, besides all that, it's important to case up any project that you plan to use on a regular basis, so it won't be destroyed by a little bit of water or a rough fall off the table. You know where I'm going here. Here's a good example. A waveform generator, aka a function generator, is a useful tool to have around when working with electronics. It's often used for testing and, well, any situation that needs a constant pitch or tone or a waveform. I could really use one for testing audio filters. So, I'm going to build this function generator kit from Jameco.
I've got my manual, PCB and parts. This won't take long. And done. Yeah, that was quick.
Once the board's fully assembled, I need to figure out how I want to wire all my off-board parts, the ones that'll be mounted in the enclosure.
The kit's instructions call for 2 additional potentiometers to control frequency and amplitude, a rotary switch for frequency range, and a toggle switch to select triangle or sine wave output. I'll also use a DC jack with a power switch and an LED to indicate when the box is turned on. Plus, I'll add jacks for connecting to signal outputs and the 2 control inputs. Yep, that's pretty much everything.
Almost any suitably sized wooden or plastic box would work as an enclosure, even say a cigar box, which is all this guy really is. For my function generator, I settled on this basic black project box. It's sturdy, but it has thin plastic panels so they're easy to drill and mount parts in.
Planning my control layout is pretty simple using some of the actual hardware I'll be mounting later on. Deciding which layout I like best can be a bit tougher, but that'll work. I'll take some basic measurements to specify exactly where I want everything, and mark the spots I need to drill. Not to forget holes for the PCB standoffs. Once that's done, it's drilling time. Ideally, I'd use a drill press, but basic power drill will work fine. Some scrap wood will help support the panel, and a couple clamps secure it all in place. Looks good to me.
Now, I can mount all the parts in my enclosure. You'll notice that the pots and rotary switch each have a little stabilizer post on them. I could drill small holes alongside their main holes to accommodate that stabilizer post, or I could simply pop it off with a pair of needle nose pliers, like so. Problem solved.
I generally tighten each part by hand first, and then go in with a socket set and a pair of needle nose pliers to make it all permanent. Just to be sure I don't get them confused, I'll measure and mark the value of each potentiometer. A multimeter's continuity function comes in handy for marking which connections to use on the rotary switch, because there's quite a few of them. And of course, if we're going to be wiring, we'll need some wire. 22 to 24 gauge stranded type wire works well for this sort of thing. Prepping many pieces of wire can take a long time, but an automatic wire stripper does make things go a lot faster. And the tip tinning process is a bit easier thanks to my helping hands tool.
Don't mention it. I'm here to help.
Remember to take breaks when working alone for long periods of time. Anyway. And finally, it's time to make some real electrical connections. You remember, like in the schematic before? Once all the connections are made, a couple zip ties will keep these wires in check. And wrapping things up, I'll mount the PCB in the base. Close the case up, being careful not to catch any of those wires. Put in the screws. And a few rubber feet, which are not chocolate, though they look like it. And last but certainly not least, the knobs, which are secured fairly easily using a small flathead screwdriver. And as long as everything is secure, we're totally done.
Woohoo!
Excuse me. Alright then. Pretty sure that's everything. Now just to see if it works. It's probably a good idea to test it before sealing it up, but makes no difference. Now, plug in my 12 volts, apply, LED turns on. That's always a good sign. Let's see if it makes sound. Sweet. It works. Well, that's cooler than I thought it would be. And I think I'll use it for a little more than just testing audio filters. I can add a gate mute button, and I didn't even try using the sweep input or the amplitude modulation input. Well, I got my work cut out for me. Go make something, eh?
Care to build your own little tone box? You can with parts from Jameco Electronics.